So this is video 7.2b, solving systems in 3 variables. I have the steps here. Please write them down because this is going to get pretty complicated, guys. It's messy, so you need to make sure that you are very neat in your work. You can't get sloppy here, and take good notes and make sure that you understand the examples before you come in. We'll go over it in class and we'll spend some time on this, but this can get very tedious. So go ahead and pause the video, make sure that you write these down, kind of read them through and try to understand what's going on before you jump into the examples. It'll really help you out. All right, so our first example we have here, okay? What we're going to do is take equations 2 at a time. So it doesn't matter which 2 that you take, but you always want to try to use the least amount of, or do the least amount of work as possible. So what you want to look for in selecting the first one is whichever variables can be easily eliminated or substituted for. So if you're looking at these, I'm actually going to take these bottom 2 here, because if I look at this system, I can use elimination here to create a system in 2 variables. So that's what we're going to do. So I'm going to cover this up so it doesn't confuse you. And I'm going to eliminate these variables here. Okay, so I'm just going to draw a line here and just rewrite them down here at the bottom so we don't get confused. 3x minus y plus k equals 20. X plus 2y minus k equals negative 2. So in the same way that you would use elimination with the two variable systems, you're going to do it here. K have the same coefficient of 1 and opposite signs. So I'm just going to combine these 2 equations here. So that's going to cancel. And then I'm going to combine down. So 3, this is a positive 1 here. 3 plus 1 is 4x. Negative 1 plus 2y is going to give you positive 1y, and then 20 minus 2 is going to give you 18. So now I have an equation in 2 variables. This looks familiar. You can probably deal with this pretty easy. So now I'm going to do the same thing again, but now I need to use this first equation over here. So I'm just going to write it down. 2x plus 4y minus 3k is equal to negative 7. Now, it doesn't matter which of these next 2 equations that I use, as long as I use one of them. Now, we have to eliminate the same variable. Since we eliminated k over here, we're going to have to eliminate the k from this one. So, since this is a negative, I'm going to choose this second one here because this is already a positive, and all I'm going to have to do is multiply it by a 3 so that I can get the same coefficient. So I'm going to go ahead and do that. So 3 times 3x is going to give me 9x. 3 times negative y is going to give me negative 3y. 3 times k is positive 3k. And 3 times 20 is going to give me 60. Okay, so I'm going to bring this equation down here. So 9x minus 3y plus 3k is equal to 60. And I'm going to go ahead and combine them to eliminate that k. So those are going to cancel. 2 plus 9 is 11x. 4 minus 3 is positive 1y. Negative 7 plus 60 is going to give me a positive 53. Okay, so now I have these 2 equations, and I'm going to combine them to create one system of 2 variables to solve for x and y. So I have 4x plus y equals 18, and 11x plus y is equal to 53. So I'm going to use elimination here because my y's have the same coefficient. I am, however, going to need to change the signs on one of them. So I'm just going to go ahead and make these negative here so I can combine them. So I multiplied by a negative 1. Negative 4 plus 11 is going to give me a positive 7x. My y's are going to cancel. 53 minus 18, or negative 18 minus 53, it's the same thing. It's going to give me 35. Okay, divide both sides by 7. X is equal to positive 5. Okay, so I have found one of the variables in order to solve this system. Now remember, your solution to your system has 3 variables, x, y, and k. Okay, which you have to separate by commas. So I found my x. I'm going to put it here in the solution set so that I can check it later. All right. So now that I've done this, I'm going to plug this back into one of the original equations from this section here to solve for y. I'm going to just go ahead and plug it into this one because it's a little bit easier. So we have 4x plus y is equal to 18. 4 times 5 plus y is equal to 18. 20 plus y equals 18 minus 20 on each side. Y is equal to negative 2. So now I'm almost done. The hard part is over. Now what I can do is I'm going to take these two values and plug them into one of the original equations to solve for my remaining variable, which is k. So I'm just going to pick the first one. Actually, I'll probably pick this one because it's a little bit easier. So my third step in solving it, okay, so this was step 1 right here. So that's step 1. Combining them into a system is step 2. And then my last step for step 3 is going to be to solve for the remaining variable. So I have 3x minus y plus k is equal to 20. 3 times x minus y plus k is equal to 20. 3 times 5 is 15. Double negative here is a positive 2 plus k equals 20. 17 plus k equals 20. Minus 17 on each side is going to give you k equals 3. Okay, so I found all 3 of my variables, x, y, and k, and I'm going to plug them into here. Now you have to check your work because that was a boatload of work. Easy to make a mistake. If I made one, you probably caught it, which means I'm going to have to go back and do it all over again, which is why you want to be super neat when it comes to writing these because it'll be easier for you to catch your mistakes. So let's just go ahead and check. So 2 times 5 plus 4 times negative 2 minus 3 times 3 is equal to negative 7. So 10 minus 8 minus 9 equals negative 7. 10 minus 8 is 2 minus 9, negative 7. So far, so good, right? First one checked out. 3 times 5 minus negative 2 plus 3 equals 20. 15 plus 2 plus 3. All right, we're looking good. 15 plus 2, 15, 16, 17, 18, 19, 20. Okay, so the first one checked, the second one checked. Now we're going to check the third one. X plus 2 times y minus k equals negative 2. So 5 minus 4 minus 3. 1 minus 3, negative 2. All right, so worked out good, checked out. We know that we are correct. And that is how you solve a system in 3 variables. I'm going to go ahead and do one more example for you. Now, there's more than one way to solve these equations, guys. So in the same way that you could either use substitution, elimination, or graphing to solve a system, when you come to your second step here that we did, you can also use substitution to solve. You don't have to use elimination. So here, if you wanted to, you could have solved for x or for k, and then substituted into, your third equation to solve for it. You want to just go ahead and kind of pick what works best for you or what you feel more comfortable with. All right, in our second example, we're going to go ahead and follow our steps. So we're going to take two of these and eliminate one of our variables. So if you look at these, you'll see that the first one and the last one are already set up. They have the same coefficient of 1 for k, and they're already opposite signs. So I'm not even going to fight with it. I'm just going to take this one and that one and combine them down here. So x plus y plus k equals 5, and 2x plus 3y minus k equals 8. Okay, so knowing that, I'm going to have to take this one next. So 5x plus 5y plus 5k equals 20. And I'm going to have to set it up with one of these other two to eliminate k. Since I'm eliminating k here, I have to eliminate k here. You have to eliminate the same variable in each of the systems. So since I'm taking this one, this is positive k, I'm going to go ahead and take the one on the bottom because they already have opposite signs. So we'll deal with that later since I'm going to have to change this one. So let's go ahead and eliminate here. Those are going to cancel. 1 plus 2 is 3x. 1 plus 3 is 4y. 5 plus 8 is 13. Okay. Here, I'm going to have to multiply this whole thing by 5. So 2 times 5 is 10x. 3 times 5 is positive 15y minus 5k is equal to 40. I'll bring it down. 10x, 15y minus 5k, 40. Go ahead and solve using elimination. That cancels. 15x plus 20y is equal to 60. So now I'm going to combine these two. Here I'm going to choose which variable I want to eliminate. So if you look at these, neither of them have opposite signs, but you can choose to eliminate either one. So you can multiply this one by either negative 5 to eliminate the x's if you wanted to, or you could actually either way. So let's see what happens here. So let's multiply this by negative 5. Negative 5 times 3 is negative 15x minus 20y is equal to negative 65. And then bring this one down here. So 15x minus 20y, plus 20y is going to be equal to 60. Okay, so what's going to happen here is these are going to cancel. That's 0 and that's 0. So you're left with 0 is equal to negative 5, which is not true. That's a false statement. So when that happens, just like when you had the regular systems, this means that there is going to be no solution. Okay, these two lines don't intersect. So if these two lines don't intersect, then at no point will all three of them intersect, and you can just stop. You always want to go back, though, and make sure that you didn't multiply incorrectly so that you can check your work. Other than that, that's it, guys. I will do some additional examples and link underneath this one. Other than that, you can go ahead and get started on the homework, or shoot me a reminder if you have any questions, or ask me in class tomorrow when I see you.